Hey everybody. Last time in class we practiced writing expressions and equations to represent real-world situations. Today we're going to take a look at the more abstract forms of these expressions and practice identifying different parts of them. The parts that we're identifying are going to be extremely useful when we start doing higher level algebra. Let's start with this expression we have here in the middle. We have negative x plus 2x plus 8. The primary pieces of an expression are called terms. The terms are the pieces of the expression that are being added together. So in this case we have negative x is a term, 2x is a term, and 8 is a term. The coefficients are the numbers that multiply the variable in the variable terms. So in this case our coefficient is negative 1 because this is negative 1 times x, and in this case it's 2 because this is 2 times x. So the coefficients are negative 1 and 2. A constant term is a number that does not have a variable. So in this case, it's positive 8, because this term, regardless of what the value of x is, will always be worth positive 8. Like terms are terms that have the same variable parts. In this case, it's negative x, negative 1x, and 2x, because they both have a single x as the variable. In order to identify these parts of any expression, we always want to rewrite the expression so that it only uses addition. We don't want to use subtraction. So in this case, I have 3x minus 4 minus 6x plus 2. I can rewrite this as 3x plus negative 4 plus negative 6x plus 2. So I've completely rewritten this using only addition. So I'm going to write that down so we remember that. Rewrite with only addition. That's our first step. And now that I have this written out with just addition, I can identify all of the different things that I want. If I want to identify the terms, I have 3x, I have negative 4, I have negative 6x, and I have positive 2. Put an S after that, terms. Now if I want to have the coefficients, remember the coefficients are the numbers that are multiplying the variables. So in this case I have 3x and I have negative 6x. So one of my coefficients is 3 because it's 3 times x. And my other coefficient is negative 6. I also want to identify my constants. And in this case I have two constants. I have negative 4 and I have 2. Those are my two terms with no variables. And lastly I want to identify like terms. This is a very important idea, like terms. So like terms are terms that have the same variable parts. In this case, 3x and negative 6x are like terms, but so are negative 4 and 2. Because they don't have any variables, those are also like terms. So we actually have two pairs of like terms in this example. We're going to take a look at a few more examples. In this case, negative 7y plus 2 minus 6y minus 13. I want to do the same thing I did on my last example. We're going to change this so that it's all addition. Negative 7y plus 2 plus negative 6y plus negative 13. So I only have addition here, and now I can identify my terms. Negative 7y, that's my first term. Positive 2, negative 6y, and negative 13, 4 terms. My coefficients, I only have 2 of those because I only have 2 variable terms, negative 7 and negative 6, because those are both multiplied by a variable. My constants, my terms with no variables, 2 and negative 13, and my like terms, negative 7y and negative 6y are like terms, and 2 and negative 13. Remember, because those don't have a variable. Those constants are also like terms. Alright, in this example we have 5x squared minus 3x plus 2x squared minus 11. Same first step. We're going to write it using only addition. So that's going to become plus negative 3x plus 2x squared plus negative 11. Now our terms here are 5x squared, negative 3x, 2x squared, and negative 11. Four terms. Make sure we get the signs right. Our coefficients, here we have three coefficients. We have 5, negative 3, and 2, because those are the numbers multiplying the variable terms. Our constants, we only have one, negative 11. Now, like terms in this situation is a little tricky. We have three terms that all have an x, but we only have two terms that have x squared. Remember, to be like terms, they have to be exactly alike in terms of what variables they have. 5x squared has two x's, right? We can think about that as 5 times x, and the only like term it has in this expression is 2x squared. Because this negative 3x only has one x, it's not a like term with these two. So in this case, the only like terms are 5x squared and 2x squared, because there's no other term that has a single x, and there's no other constant. Alright, here's our last example. In this case, we have a plus 4ab minus 2b minus ab. Let's do the exact same thing we've been doing. We're going to rewrite this using only addition. A plus 4ab plus negative 2b plus negative ab. Now our terms, we have four terms. Once again, a, 4ab, negative 2b, and negative ab. All four terms here. Now our coefficients, this one's a little trickier. Our first term here, notice we have a, positive a, right? Since that's just one a, we say the coefficient is 1, because 1 times a just gives us a. 4ab, our coefficient is 4. Negative 2b, our coefficient is negative 2. And with negative ab, because we have this negative ab, that means we must have taken ab and multiplied it by negative 1. That's how we got a negative sign on it. So we say our coefficient is negative 1 for that one. Now our constants here, we have no constants. We can write 0. And like terms, now we only have two terms that are like terms, and it's the ones that have the exact same variables. 4ab and negative ab are the only terms that have the exact same variables. So 4ab and negative ab. So you might have noticed, once we have our expression written out, these problems really aren't too difficult, but they are extremely important. So make sure when you're doing these problems, take the time, write the expression out using only addition, write it out the right way, and that way we can get these next four questions answered pretty easily.